Hello and welcome. In this tutorial, we are going to improve the visual representation of these gyroscope accelerometer readings. We're going to make it so that there are no crazy spikes. It's going to look just like this. And we're going to achieve this by using a moving average. Or not so moving average, we're going to take 5 values and then we are going to average them out. So just to give you an idea, by the way, in the last video, this probably should have been GZ here, but this is where we are starting from. And what you're going to see is that the signal seems fairly noisy. Right there, watch. So any type of slight touches lead to these crazy sort of spikes. And what we want to do is eliminate that and just have it sort of be a little bit more robust. So the way we do that, I think the simplest way to do that would be to have this reading done 6 times, 10 times, 20 times. We can try different amounts, and we can create a function with an that returns a long. So we could say get average, and inside this function, it doesn't take in any parameters, but it certainly puts them out. So inside here we can have a total, and a total can also be a long total. We can have the total can now be a sum of various readings. So total equals to total, and let's say we are measuring GZ here. GZ. So total is going to be total plus GZ, and the secret is to just repeat this. Let's say we repeat it 20 times, okay? If we repeated it 20 times, then we could return the average. You could say return total over 20. Done. So all we need to do is put this into a for loop for int I equals to 0, I less than 20, I plus plus, open curly, close curly. So this is going to produce that total. We're going to return total over 20, and instead of printing anything complicated, we can serial print line, and we can just say get average. That's it. So we just call this function. So Control T, I think everything is in order. We should set total to 0 just in case. I'm going to drag this over. Yep, that looks fine. I think we can try this out. We may obviously have to multiply the this guy here by like a reduction factor of whatever we used last time. I think it would have been like 0.05 or something like that. But we can start right here. So let's see. Oh, it's going to be way down, I think. We should make it return 500 plus, so we have that there. Total accel gyro GZ. This should work. Let's try that. Oh, we don't need to get this reading every time in the loop, and somebody's got to have a delay 1. So maybe just trying to get all of these readings as quickly as possible without a delay is what messed us up, but let's have a second look. That's much better. So it is hypersensitive, but it's virtually plotting a flat line here. So all I need to do is take this back into our multiplier, and I think, you know, times point. I don't remember, I think like 0.05. Yeah, 0.05 will do. Let's run this. My goal is that we just see a flat line when the thing isn't moving. It should be that capable of at least doing that. Yes, that's it. Perfect flat line. So turn this way, turn that way. And if you turn fast, you're going to go all the way to the top, or all the way to the bottom. Which makes me think, actually, if I can get this so easy, it could even be more sensitive. I'll try 0.02. And there you have it. I mean, that is a pretty good-looking moving average. No meaningless sudden spikes. So, like, ultimately the test may be to get some extra brackets around the total here, because the BODMAS may have tripped us up. Let's go. That's pretty neat. So, as you can see, with the gentle touches, nothing crazy happens. There was that one spike, but other than that, nothing. And I should be able to go all the way. All the way. And I'm wondering if we can simply swap this out for another axis, or for maybe the accelerometer. So you can try AX. Upload that. Let's see. Are we seeing a flat? Is it working? Okay. So that axis is definitely not the X. That one. I think up and down would be AZ. So I'm going to try AZ. And clearly, this level of forcing might have been suboptimal, but I think this is going to look good. Ah. What did I do? How did it get so huge? Divided by 0.05. Yeah, make it 0.03. And we can even average out more than 20 values. Maybe make 25. AZ actually includes gravity. Watch this. This is going to be interesting. Probably, yeah, drops down to 50%. Right. That's gravity right there. Gravity. And now we can, and you can sort of see how powerful gravity is, because even the sort of shock that the inertia of me doing this isn't as much as just gravity acting on it. That's pretty amazing. So there you have a much more leveled out, averaged sensor output. So we are going to be done with processing. I'm not going to do that much more than that. I hope that you guys can perhaps look in your own time inside the processing documentation, see what else you can do, play perhaps with the colors of the graph and the dimensions some more. And for us, we are going to go into looking at saving some data on an SD card in the future. So see you in those tutorials.